Okay, let's talk about section 1.5, solving inequalities. Okay, so first, let's review the interval notations. Notations. Okay, so here, first, let's see the definition. An open interval denoted by parentheses a and b consists of all real numbers x for which x is between a and b, excluding two extreme points. Okay, so this is an open interval without a and b. A closed interval denoted by bracket a and b consists of all real numbers x for which x is greater than or equal to a and less than or equal to b. So closed interval includes two endpoints. A and b are inside the closed interval. Okay, so that's the difference. And of course, sometimes we just include one endpoint and free the other endpoint. They are called half open or half closed interval. Okay, so the half open or half closed interval are parenthesis a bracket b. This consists of all real numbers x for which x is greater than a and less than or equal to b, because here you use bracket to include b. So this is one possibility, and bracket a parenthesis b is another type of a half open or half closed interval. So consists of all real numbers x for which x is greater than or equal to a and less than b. So this is our open, closed, half open, half closed intervals. So in any way, if you use bracket, it means you're going to consider this point and the point. If you use parentheses, you're going to ignore this point, exclude this point. Okay, and by this, all these settings, a is the left endpoint and b is the right endpoint. Okay. Okay. So this is a interval bounded, it's definitely between two numbers. And sometimes you only need the x to be greater than a number or to be less than a number. So you don't have the other part. So we will have the other type of interval. We put bracket a infinity, means the set of all real numbers so that x is greater than or equal to a. If you use parentheses, it means you're going to exclude a. Okay, so this is the set of number which is strictly greater than a. And you can also put a on the right hand side. If you have a negative infinity, a with a bracket just means x is less than or equal to a. Or use a parenthesis means x is strictly less than a. Okay? Or you can say I have any condition about x. X is free. So it's from negative infinity to positive infinity. In this case, x is really free. So it's x is a real number. That's it. All real numbers. Okay, so that's our interval. And when we have intervals, we can graph them. You see, if you have a and b, closed interval a, b, you draw the number line, you put the origin, and you have a and b. You also use a parenthesis to indicate this is the interval a and b. If you use closed interval a, b, you are going to use bracket over the number line to demonstrate the closed interval a, b. Whenever you use some symbol, when you draw the graph it on the number line, you will use the same symbol. For example, if you have negative infinity a, you will have this. You have a, you get a bracket. Have a, you get a bracket. Okay, this represents you are going to choose this piece. If you use a positive infinity, you see what this is a. You're going to get this opening to the right. Okay, so that's the graph of intervals. There is a table 1 on page 120. It gives you the complete graphs of all the different types of intervals. Okay. So for example, if we have a condition written by the inequality, x is is greater than or equal to 1, less than or equal to 3, then it is equivalent to say the interval, closed interval 1 and 3, because here it contains equal conditions, so you use a bracket, it's a closed interval. If you have negative 4 less than x less than 0, because this part there's no equality, so you have negative 4 and 0 and with the parentheses. See, if you only have x greater than 5, there's no second condition, so it's a 5 infinity, because here it has no equal sign, it's an open interval. Or D, if you have x less than or equal to 1, okay, on the left hand side, so it's negative infinity 1, because you have the equality, so it's a closed interval. It's a half open, half closed interval. And be careful, we always put a parenthesis for the infinities, because x is a number, x is not infinity. So you will never put bracket, you will not put a bracket for the infinity. Okay, so that is the review of the interval notation. Now let's see the properties of inequalities. Use properties of inequalities. There are several basic inequality properties. Okay, so when we say a number, you will see a positive number or negative number or zero. And sometimes we combine this positive number and the negative number, combine them together and call them non-negative number. Sorry, positive number 0. We combine positive number 0 together, we call them non-negative numbers. So positive numbers union 0 are non-negative numbers. So when later when you see non-negative, means it could be 0, it could be positive. Okay, non-negative numbers. The first property for the inequality is so-called non-negative property. It says for any number, real number a here, let's emphasize it's a real. For any real number a squared is always greater than or equal to 0. So this is a non-negative property. It can be 0. When a is 0, 0 squared is 0. When a is not 0, either positive or negative, a squared is always a positive. Okay, so this is non-negative property, and this property only works for real numbers. Remember that for the complex number, we have the example. I squared is equal to -1. So this property only works for real number. It does not work for the complex number. Okay, and second, addition property of inequalities. Addition properties. It means if a is less than b, then a plus c is less than b plus c for all c. The other one, if a is greater than b, then a plus c is greater than b plus c for all c. So you can add arbitrary number to an inequality and keep that inequality. Basically, addition means a shift. So, for example, if you have 2 less than 1, you add a 3, you get a 4 less than 5. You just shift. 1 is here, 2 is here. Just shift this relation, relative relation, to 4 is here, 5 here. You move them together 3 units to the right. So this is a 1 plus 3, 2 plus 3, 2 plus 3. You move them together, together, then you don't change the inequality. Right? So this is the addition property of inequalities. Okay, now let's see some example. If x is less than -5, then we add 5 for 2 sides. We will get x plus 5 less than -5 plus 5. So x plus 5 is less than 0. Right? So this is our inequality. And because you see here, when we add 5, we always cancel the original quantity. 5 is especially selected. So when we add this 5, the negative of it we always cancel this the original term, get 0, and leave the negative number on the right hand side, negative of the original number on the right hand side. 5 is a negative and negative 5. So here we can say that we move negative 5 to the other side, and change it to positive 5. When you move a term cross an equal sign or cross an inequality sign, you always change the sign. Whenever you move it cross the relation. If you move it in the same side, you do not change anything. But if you move it cross the relation symbol, you are going to change the sign. All right? B, if x minus 2, x is greater than 2, let's see how do we understand it. There are two ways to understand it. First way, we subtract 2 from two sides. 2 minus 2 is 0. The reason we subtract the inequality by 2 is that we want to cancel, we want to make the right hand side 0. 2 minus 2 is 0, so it's x minus 2 is equal to 0. Or you can say that this number 2, we're going to move it from right side to the left side. Whenever you move it cross this relation symbol, you're going to change the sign. 2 originally has a positive sign. When you move it across a symbol, it becomes a negative sign. Since you already move 2 to the left side, the right side becomes 0. The right side becomes 0. Nothing left. Okay, so the same result. Either works. It's up to you, and you select your favorite way. All right. And then we have the multiplication property. Of inequalities. Multiplication property for inequalities is a little bit complex than the addition property. The reason is that for the addition property, you can add whatever number, positive or negative, you always keep the direction. But the multiplication is different. If C is positive, if you multiply inequality by a positive number, then from A less than B, you will get AC less than BC. From A greater than B, you will get AC greater than BC. So you multiply the inequality by a positive number, you still preserve the direction of the inequality. If C is less than 0, then A less than B will imply AC greater than BC. You have to change the direction of inequality. A greater than B imply AC less than BC. Be careful about the difference. Be careful. And of course, if C is 0, then for whatever inequality, you will get a 0 equal to 0. It's trivial, it's nothing, because 0 times whatever number is always 0. So you change the inequality to the equality. This is not allowed. We want to preserve the inequality. Okay, so we never multiply inequality by 0. All right. So the multiplication is done this way. You do the multiplication with a positive number, you preserve or you keep the direction of inequality. If you multiply it with a negative number, you're going to change the direction. For example, If 2x is less than 6, we multiply two sides by 1/2. Or you can say it, we divide it. Well, division is another way for the multiplication, right? Divide it by 2, the same thing. Divide by 2, it is equivalent to say multiplied by 1/2. Then the left side, because 2 or 1/2, they're both positive, so it becomes, let's do the multiplication, so x is less than 3. 2 times 1/2 is say 6 times 1/2 is 3, so x is less than 3. All right, and if x is over -3 is greater than 12, then we multiply it by -1/3. We just clear the coefficient of x. If you have 2, you divide by 2. If you have a denominator -3, you multiply by -3. Because here -3 is negative, so when you write the inequality, you change it from greater than to be less than. And -3 cancelled with this -3 from the denominator. And the right hand side is 12 times -3. So this implies x is less than -36. Okay. Okay. Another thing, reciprocal property. Reciprocal property. What is the reciprocal property? If a is greater than 0, then 1/a is greater than 0. If 1/a is greater than 0, then a is greater than 0. Okay, this is the reciprocal. When you flip a positive number, you get a positive number. Actually, the second one is redundant. A is 1/1/a. So the second part is the same as the first part. And similarly, if a is less than 0, then 1/a is less than 0. If 1/a is less than 0, then a is less than 0. So negative number has negative reciprocal, positive number has positive reciprocal. All right? Okay. Okay, let's stop this video for this for the current topic, and in the next subpart, we are going to really solve the inequalities. I'm going to keep that part complete. So I stop this video, and we will start a new video to continue the discussion. Okay. Thank you. Bye bye.